evaluate the temperature at which there is 1% probability that a state with energy 0.5 electron volt above Fermi energy will be occupied by electron. So this is the question. So the first thing that we should look into it, that which statistics does this question to evaluate the temperature lead to. So because this problem is on electron and there is Fermi energy, so we have to write the probability or distribution function formula. So the probability or distribution function F equal to 1 by e to the power of E minus EF divided by KT plus 1. So what is FE? FE is basically probability and its given value is 1%. So I can write down as 1 by 100. And so F is the probability, E is the energy, EF is the Fermi energy, K is the Boltzmann constant, T is the temperature. So in this problem, probability is 1%, and this is very important. Energy, that a state with energy 0.5 electron volt above Fermi energy. So the energy value where the electrons are residing is 0.5 electron volt plus Fermi energy. Why? Because please read this statement. A state with energy 0.5 electron volt above Fermi energy. That means it is that energy level which is 0.5 electron volt excess of the Fermi energy. So energy is 0.5 electron volt plus Fermi energy. And the Boltzmann constant is 8.6 10 raised to minus 5 electron volt per Kelvin. Now this value you have to memorize it because this is a constant value. So what we have to find out? We have to find out the temperature of the electrons present in the energy whose value is 0.5 electron volt above Fermi energy. So you have to calculate the temperature. So in this formula, we know the value of probability, we know the value of energy, we know the value of Boltzmann constant, and we can calculate the temperature. Let us substitute these values. So probability is 1%, so I write 1 by 100 is equal to 1 by e to the power of this energy I would write as 1.5 plus Fermi energy, that is EF, and minus EF is already there in the formula, divided by KT, where K is Boltzmann constant, T is temperature. So what happens? This Fermi energy plus EF minus EF, they cancel in the formula, and I have 1 by 100 is equal to 1 by e to the power of 0.5 KT plus 1. So if I know already the value of Boltzmann constant, we have to memorize it or remember the value of Boltzmann constant. So if I substitute the value of Boltzmann constant, I can calculate the temperature. Now, moving without calculator, let us go ahead with some steps without calculator, and finally when I require, I can use the calculator as a student. So, what I will do, I will consider let 0.5 by kT I would consider as x. So in this formula, 1 by 100 is equal to 1 by e to the power of x plus 1, because 0.5 kT I have considered as x. So 1 by 100 I can write down as 0.01 equal to 1 by e to the power of x plus 1. Okay? And then from here I can write down e to the power of x into 0.01 plus 0.01 equal to 1, or e to the power of x equal to 1 minus 0.01 divided by 0.01, which I have as 99. So this equation, e to the power of x equal to 99. So I'll take log, because I want to have the value of x, and then I substitute the value of x here, then I get the value of the temperature. So what I can do, I will take to get this value as x, I will take log on both sides. So taking log with base e on both sides, that means multiplying log base e on both sides. I have x is equal to ln 99, and the value of ln 99 is 4.59. So I have the value of x equal to 4.59. Now if I substitute the value of x here, so what I'll have? I will have x is equal to 0.5 by kT. So T is equal to 0.5 by K into X. So T is equal to 0.5 into Boltzmann constant, which is 8.6 10 raised to minus 5 into X. The value is 4.59, and the temperature is roughly 1260 Kelvin. So that's the answer. Calculate the average energy if the Fermi energy at thermal equilibrium is 15 electron volt. So we have to calculate the average energy, and the Fermi energy is given. So what is the relation between Fermi energy and the average energy? The relation is average energy or sometimes it is said mean internal energy which is denoted as E bar is equal to 3/5 of EF, where EF is Fermi energy. EF is Fermi energy. Okay. And what is the value of EF given in the problem? It is 15 electron volt. So we use the formula E bar, which is average energy, 3/5 of Fermi energy, and 3/5 into 15. Because Fermi energy value is 15 electron volt, I have 9 electron volt after calculation, that is the average energy. So these two problems, they are very important from the chapter Statistical Mechanics, and these two problems are also important in terms of semester paper. Thank you so much.